So in the last video we talked about function as a rule. Now in this video we're going to talk about function as a machine. So let's do the review of the last idea we have done. Okay, so if we have element x1 in x and there is element y1 in y, they are connected. Okay, now for every x1 there must be a unique element on y1. It cannot have more than one. If we have now, if x1 is connected to over here, so if it is connected to y's, so now that means the x does not have a unique destination, it doesn't have unique y's. Okay, so this is not a function. So that was the basic concept that we discussed. Now we'll talk over here function as a machine. Now to visualize function as a machine, so you can think a certain kind of machine. Okay, so this machine is called the F machine, the function machine. Now what it can do, okay, it can take certain values. Okay, these are the input side, so we call them input set. Okay, so it takes certain inputs, okay, and from that input it gives you certain output. Okay, so we have output sets. Okay, now when you put certain values over here, okay, now this as a function, what does it do? It process on that value, whatever we keep over here, it does some processing, and after doing processing it release out as a output. Now for example, if we keep x over here, consider the function to be f of x. Now what will be the result? The result will be f of x. Okay, now all the x values that we keep in the function machine, this set, the input set, this is called domain. Okay, we call it domain. Okay, so and all that comes out from this function machine, we call them as a range. Okay, that's called range. Let's just review what we have talked up to now. So we have a function as a machine, so the machine does certain process. Okay, now you have a certain input set. Okay, from this input set we choose x, okay, a random variable, and we keep this into the function machine. The machine processes out and gives you the value y1. Okay, so all the input set is called domain, whereas the output set we call it as a codomain. Okay, now I want to give you some more terminology, something more. Now let's talk about another thing. Now say I have taken a particular example. If we keep a x1 in the function machine, let's consider this function machine to be f of x. Okay, when you keep in this machine, the machine does process and give you the result f of x1. So this f of x1 we call it y1. Okay, now here the y1 is called image. Okay, so it is the image, so this is called image, and since this is called image, the y1 over here, these x1 and y1, these two are connected. So if this is the image, the x1 is called the pre-image. Okay, now the next thing, the set of image. Okay, now the set of image y1 y2 dot dot dot, the set of image we call it range. Okay, we call it range. Now there is a difference between the range, and codomain. Okay, though they are similar but they are not exactly the same. Now if we consider, okay, in our above example, okay, now there could be certain value over here which has no association with the input set. Okay, so that will, if that is the case, in that case range and codomain will not be same. Let me illustrate with an example what I mean to say. So if in this example we see over here all the x1s, every x1 must be connected with a unique element of y's, and we see that x1 is only connected to y1, so it has a unique element. Y1 is also connected only with y1, so it has also a unique one. Now x3 is connected to y2, but y3, if we see over here, now y3 has no correspondence in x. Okay, now this means y3 is alone. Now say If we talk about range, now what are the ranges? If we talk about the range, so the ranges are y1 and y2. Okay, but if we talk about codomain, if we talk about codomain, now codomain will be y1, y2 and y3. From here we can see that codomain is the superset of range, and whereas the range is subset of codomain. Okay, but you can't have an extra over here. Just if you do like this, now this will not be a function. It won't be the case of function. For a function, it is always a necessary condition that every element in the X must be associated with a unique element in the Y. We talk this in the function as a correspondence. So up to now we have talked about certain things. We talk about function as a correspondence or a rule, and we talk about domain. Now domain are the input, we talk about that. Okay, these are the input sets, and no member must be left. All the member must have domain must be associated. Now similarly we talk about codomain. Now codomain is the output set. Okay, and we talk about range. So there's a difference between codomain and range, which we just talked above. Okay, now next thing we talk about image. Now each member of range, okay, each member of range, for example in the above example over here, y1 and y1 is the image and y2 is also image. So y1 is the image of if you see in the diagram, though I have made a messy, you can see over there, y1 is the image of x1 and x2, or you can say x1 and x2 are the pre-image of y1. Okay, so we talk about image, and next thing we talk about the pre-image. Now pre-image are the element. Okay, these are the element present in domain. For example, x1 is the pre-image of y1. We have already said that. So x1, x2, x3, so this individual, they are called the pre-image. Okay, now in the next video we'll talk furthermore concept of identity function, inverse function and composite function, the most important one, which you are mostly asked a question in a SLC examination. Thank you for watching this video.